Okay, so we'll be looking at sketching graphs of cubic polynomials and their moduli. So these are questions extracted from the IGCSE Additional Mathematics series. So the instruction says we should answer our questions and show all necessary workings. Question 1. Find the coordinates of the points A and C where the curve intersects the x-axis and the point D where the curve intersects the y-axis. Okay, so clearly we're also going to find point B. Okay, so what happens here? This is the equation given to us. Y equals to x minus 4, x plus 2, x minus 5. So let's quickly work out what this will be. So we equate this. First of all, how do we find the x-intercept? So for the x-intercept, we see that we make y equals to 0. Good. So this becomes x minus 4, x plus 2, x minus 5, everything equals to 0. So this implies that x minus 4 is equals to 0, or x plus 2 is equals to 0, or x minus 5 is equals to 0. So obviously, from our knowledge of equations, if the multiplication of these three factors will give us 0, it means that either one of them is equals to 0. So this implies that the first intercept is x is equals to 4. We get the next one. This means x is equals to minus 2. Then finally, we have x is equals to 5. So merely looking at this curve, we can actually make out where these points will be on the x-axis. We know this is the y-axis, and here we have the x-axis. Okay, so let's look at the negative 2. So A certainly will be, so we can say A is equals to minus 2. So here is minus 2. We'll label it correctly. Okay, and then the next one, x is equals to 4. This point should be 4. Okay, then we have x is equals to 5. C should be 5. So we've obtained the values of A, B, C. B is equals to 4, and we have C is equals to 5. Now, how do we get point D? Okay, so to get point D, that is the y-intercept. For the y-intercept, we make x equals to 0. So do the opposite of what we did when we're looking for the x-intercept. So we make x equals to 0. So this implies that y is equals to, so this will be 0 minus 4, 0 plus 2, 0 minus 5. So effectively we have this as minus 4 times 2 times minus 5. So therefore we see that the y-intercept, which is the same thing as point D, is equals to 40. So we can come here, we say D is equals to 40. Okay, so this is all we need to do to answer this question completely. So we found the intercepts. The x-intercepts are A, B, C, and the y-intercept is D. Question 2. Sketch each of the curves and indicate clearly the axis intercepts. So we are required to sketch these curves. So what do we do? The first thing is let's get the intercepts first. So the x-intercepts, to get the x-intercepts as usual, we make y is equals to 0. So y is equals to 0. This implies that the x-intercepts will be x minus 1 is equals to 0, and x minus 4 is equals to 0, x plus 2 is equals to 0. So finally x is equals to 1. Okay, then the other one will be x is equals to 4. Then we have x is equals to minus 2. So these are the points where the graph, this cubic graph, will cross the x-axis. Now let's find the y-intercept. So we make x is equals to 0 to find the y-intercept. So from our equation, this y becomes 0 minus 1. We substitute anywhere we see x, we substitute 0. And this becomes 0 minus 4. And we have the last one as 0 plus 2. So minus 1 times minus 4 times 2. We see therefore that the y-intercept will give us 8. So with this, we can now sketch our graph. Pick this up. So we have, this is our y-axis, and this is our x-axis. So we choose convenience scales. X ranges from minus 2 to plus 4. So I could come here and say, here is minus 1, 0, minus 2, minus 3. Okay, then I have here to be 1, 2, 3, and 4. Okay, y is at 8, so we could use a scaling of 2, 4, 6, and 8. Okay, so let's pick those points. Our intercepts are at x is equals to 1. Okay, x is equals to 4, and at x is equals to minus 2. So okay, and the y-intercept is at this point. Now we need to understand something. What will be the shape, general shape of this graph? Now the very fact that there's something we need to bring out. Okay, imagine a constant here, k. Let's write the general form of this equation. Okay, there is something we need to understand for us to be able to tell the shape of this graph. So the general form of this cubic equations is written as, so we have the general form or the shape. So this is what we're going to have. Y is equals to k. So you have x minus a. You have x minus b. And lastly, you have x minus c, where a, b, c are the points where it crosses the x-axis. Now, the general rule of thumb we should follow is this. Number 1, if k is greater than 0, the shape of the graph will look like this. This will be the shape of the graph. It will look somewhat like this and like this. Good. Now, in the event that k is less than 0, k is less than 0, the shape of the graph will be the opposite, and the graph will look like this. Good. Now, in our own case, k is 1, so 1 is greater than 0. So certainly the shape of the graph will look like I. So let's move. We see that a graph should look somewhat like this. We come here. Okay, and that is okay. So certainly, if we test for infinity, we're going to see that there will be infinity here, so we can extend it to show that these two sides, these two tails, they tend to infinity as we plot this graph. Okay, so once we understand this, we can almost immediately sketch any cubic graph that will give to us. So let's move on to the next question. So let's look at question 2b. So based on our work, we can easily obtain the intercepts. So x is equals to -1, x is equals to -2, then x is equals to 4. So all of these gives us our x-intercepts. Now let's calculate our y-intercept. So for the y-intercept, we have y is equals to, substituting 0 for x is here, we're going to have 1 times 2 times 4. So this gives us 8. So this is our y-intercept, the point where the graph crosses the y-axis. So we can easily sketch our graph at this point. So we have it this way. Now let's look at values of x, ranges from -2 to +4. So have -1, -2, -3. Here we have here 1, 2, and we have 3. Okay, so these are x-axis. Then for the y-axis, our y-intercept is 8, so we can select 2, 4, 6, and 8. Okay, so let's mark out those points that we are interested in. Our intercepts are at -2, so this is a point, we're interested in this point, minus. Okay, so we have our points. These are the intercepts: -2, -1, and 4 on the x-axis, an intercept of 8 on the y-axis. Now we see that there's an issue here. This is 4 minus x. 4 minus x. K, this implies that k, if we expand correctly, k will be the coefficient of x squared. K will be less than 1. Now, if k is less than 1, that will affect the shape of our graph. So we expect that the shape of the graph will look somewhat like this. Going to come like this and that. So this is exactly what we expect here. So we start here. Okay, we move over. We try to get to that intercept. Then we cut at x is equals to 4. So these graphs, based on the values we have here, they are going to extend. Okay, so that's how it's going to look. So this is the shape of the graph. Okay, very important to understand, because of this switch of 4 minus x instead of x minus 4, k ends up as less than 1. So the shape of the graph will look like this. Now let's take another example. C, let's quickly calculate our x-intercept. So for the x-intercepts, y is equals to 0. So x-intercepts, we make y is equals to 0. That leads us to 2x minus 3 is equals to 0, which implies that x is equals to 3 over 2, which is 1.5. Okay, now we have the same thing, or 3x plus 1 is equals to 0. This means that x is equals to minus 1 over 3, which is equals to minus 0.3. So last one, we have x minus 3 is equals to 0. So this means that x is equals to 3. So we've all gotten our intercepts, our x-intercept. Now what of the y-intercept? How do we compute our y-intercept? So we come here, we have y-intercepts. Okay, we make x is equals to 0. So x is equals to 0 for the y-intercept. This gives us y will now become minus 3. Okay, 1. Then you have minus 3. Okay, so basically y is equals to 9. So we can sketch like before. Come here, we have this. Label our axis. This is the y-axis. This is the x-axis. So the values of x ranges from the lowest value is negative 0.3. Okay, then let's see. So we have here, this is negative 1, negative 2, negative 3, and so on. So here we have 1, we have 2, we have 3, we have 4. Okay, of course, on the y-axis, negative 1, negative 2, negative 3. And let's look at this. If we take here to be 2, take here to be 4, we have 6, 8. I had to extend this to 10 because we're interested in y is equals to 9, where the graph will cross the y-axis. So that should be between 8 and 9. Now let's look at our intercept. Okay, x 1.5 is here. This is it. Okay. Then we have x is equals to 3. This is a point here. Then we have x equals to negative 0.3. 0.3 will be somewhere here less than 0.5. Okay, so we have everything we need to sketch this graph. Okay, I like to use a different pen for this for clarity. So let's pick this up. See, it's going to be like this. Now the reason it's like this is, in this case, our k is it should flow out somewhat like that. Our k here is greater than 0. Okay, so our k will be greater than 0. But if we expand this, the coefficient of s cube is certainly greater than 0. So the graph will have this shape. So what happens that so far everything that we've done here, and we test it at these ranges, this is positive infinity. So this is positive infinity. Then here also going to have negative infinity. Okay, so the graphs will extend indefinitely in the positive and the negative end. So pretty much all of these are done the same way. We can also proceed to do the last one. Okay, so let's see how we can sketch this one. Okay, so again, let's look at our intercepts. To find the x-intercepts, we make y equals to 0. So in that case, I'm going to have 1 minus 2x equals to 0, giving me x is equals to 1 over 2. Okay, then we have also x, let's remove that. So we have x minus 2 is equals to 0. So this gives me x is equals to 2. Then lastly, the last intercept, we have y, rather we have x plus 2 is equals to 0. So we have therefore x is equals to minus 2. Okay, so these are the intercepts, okay, for x. Now for our y-intercept, for us to get the y-intercept, we make x equals to 0. So x is equals to 0. Okay, so what do we get? Y becomes equals to 1 because 2x is 2 times 0. 1 times minus 2, okay, times 2. So here we get negative 4. Okay, so I can sketch based on these values. We come here, let's sketch. Okay, this is our y-axis as usual, our x-axis. So let's see, the lowest value of x ranges from minus 2 to positive 2. So here I have minus 1, minus 2, I have minus 3. Here we have 1, we have 2, 3, 4, and so on. Okay, for y, we have here 1, 2, 3, 4. I have negative 1, negative 2, negative 3, and here is negative 4. So let's mark out those points. We know that the y-intercept is here. Another pen. The y-intercept is here. Then x minus 2 is an intercept also. Then we have x is equals to 2 and x is equals to half at this point. Okay, so now let's look at this. Now in this case, we have 1 minus 2x. By the time we expand this, the coefficient of x cubed will be negative. So clearly we see that k will be less than 0. So as the shape of our graph is going to look somewhat like this. Okay, we see it's already playing out. So it extends indefinitely at this point. Now come here, process. Okay, then we have it this way. So this is what the shape of the graph could be. Now for the Cambridge IGCSE, we are more interested in the general shape of the graph. Okay, so we get the intercepts, the x and the y intercepts. We sketch it appropriately, how the general shape of the polynomial will look like. Okay, and if need be, we can do further calculations to get the maximum points or the minimum points of the graph. But in this case, this is not the objective. We are interested in getting the general shape of these cubic polynomials. So this brings us to the end of this solution set. Kindly like, share, and subscribe.